Hi, my name is Alejandra Lopez, and I work in the Physics Institute at the National University of Mexico. Let's share the presentation. I will talk you about the comparative study of zinc oxide thin films' physical properties when they are deposited with different solvents. This work is presented in collaboration with Professor Dwight Acosta, Dr. Carlos Magaña, and myself. Let's start with the experimental. The zinc oxide thin films were prepared on a substrate of soda lime glass using the spray pyrolysis technique using three different temperatures, 400, 450, and 500 degrees Celsius. The precursor solution used ethanol or methanol as solvent during the sample preparation. And then we studied the structural, optical, morphological, and electrical properties. And the following are the results that we obtained. First of all, we have to calculate the atomic concentration of the film and the thickness. The thickness and the atomic concentration were studied using Rutherford scattering spectrometry during this kind of experiment. The alpha particles lose energy in different ways, depending on the atom they collide with or according to the depth the atom is located. Then, by calculating the stopping power, this is the stopping power of the alpha particles in each of the elements that form the material, in this case, zinc or oxygen, and we can calculate the thickness of the material using this formula. Here we have the stopping power. By using the stopping power, we can calculate the energy loss factor, and then we measure the energy loss of the alpha particles in the RBS spectrum. So we obtain the thickness of the film. Then we study the structural results for each of the temperatures, and for ethanol or methanol. It was studied by X-ray diffraction. Here we can see the patterns. And all the patterns exhibit a Imrc structure, and the patterns provide crucial insight into the structure of the films. At 500 degrees, we can see that the samples are the more stoichiometric of all the other temperatures. The optical results are also interesting. We use the Tocque relation for analog direct transition using this equation. And we have the energy band gap for the methanol and the ethanol samples. And the optical properties reveal that the optical band gap of these zinc oxide thin films increase first with temperature and then is higher with methanol than with ethanol. They follow the same behavior as the substrate temperature is raised, and we can see from these results that the band gap can be tailored by modifying both substrate temperature or the methanol or ethanol, the solvent that we use during the reaction in the pyrolysis experiment. The morphological results show that for the ethanol samples, we have grains, rounded grains, but for the methanol samples, for the lowest temperature, we have some kind of plate-like forms that then they transform to a spherical-like shape in this case, and they remain spherical for the greatest temperature. Also, the micrographs show films that are dense, regular, compact. They have different textures, of course, different grain size and different morphologies. And we see that they depend on substrate temperature and on the solvent used. The electrical results is interesting too, because in the case of the methanol, the samples show a clear relation between the resistivity and the substrate temperature. As temperature increase, the resistivity decrease, but in the case of the films grown with ethanol used as a solvent, they first have a resistivity value, then it decreases, and then it increases again. So at 500 degrees, we can see that resistivity matches for both ethanol and methanol, almost matches for ethanol and methanol solvents. For the conclusions, we can say that our findings show that the optical, structural, morphological, electrical, and elemental concentration properties of zinc oxide thin films can be adjusted to suit for example, the optoelectronic applications, just for varying the precursor solvent or also the temperature. It was also observed that at 500 degrees, the zinc oxide films prepared with either ethanol or methanol exhibit almost the same physical properties. This is really interesting. And our results indicate that the choice of the solvent, medium, and substrate temperature are crucial for obtaining high quality films and tailoring their physical properties. Okay, thank you very much. Muchas gracias. Let's stop and stop recording. Thank you very much.